Hello, everyone. Welcome to our first edition of Virtual SIGGRAPH. As we all know, the shows are not taking place physically anymore, but we try to communicate with our audience. We try to find some educational content that we'd like to share with you. And today we're going to talk about some very, very trendy topics that are emerging technologies in the world of immersing media and immersive media and visual effects and computer graphics. And with us, we have our good friend Nick at Drexel University. Nick runs a fabulous lab, VR, immersive technology, virtual productions, green screen, anything that is advanced technology and advanced media. I think Nick is really well immersed with him and his curriculum, to offer his students. So before we dive, into one of the really sort of prominent topics in the industry, which is virtual production, and I'd love to have your take on it. Tell us a little bit about your activity, the lab that you run. When did it start? I remember you and I talking about 360 VR for a long time, but now you're diversified and you're doing a lot of different things. So tell us a little bit about it.
Sure. Thanks for having me. And, we started out at Drexel with a digital media program department that started over 20 years ago. In fact, this past June, our 20th graduating class completed their degrees. So we've been at this for a little over 2 decades now. And along the way, the growth in the industry has led us to then branch out into specific programs for areas such as game design and animation visual effects and interactive digital media. Along the way, while the industry developed specializations in these spaces, there became a convergence of these different technologies, particularly when it came to immersive media and virtual reality. As that gained traction in the industry, it was leveraging all the things that we had now specialized in. There were specialized industries for game design, specialized animation, specialized visual effects. So we saw a need to create a new program in immersive media that brought them back together as well. So a few years ago, 2018, we launched our VR and immersive media program, and that really brings within its umbrella all of the skill sets that we use in game design and interactive digital media and animation visual effects. And we view VR immersive media really as a very broad umbrella category of technologies and skill sets. So students are learning about game engines, but they're also learning about 360 and VR cameras. It's not just virtual reality in terms of headsets and AR headsets, but it could also involve projection. It could involve large format screens, LED panel screens. It could involve entertainment, or it could involve aerospace or museums and scientific discovery. And so it's this much more broad category of study, and it's been fantastic. So with that already created as a particular area, the things that we've been studying, including match moving and motion capture. So we have 2 motion capture stages now, combining that with what we know about animation visual effects, as well as real-time game engines. All of that is now coming together in the industry at the same time. And we're seeing, especially with the new social distancing requirements, that virtual stages, virtual sets are becoming increasingly more important in broadcast production, as well as features and episodic production. And so it's a really great space to be in right now.
So you sort of orchestrated a transition to make sure that you were involved in virtual production, especially in regards to game engines, and Unreal having made, so many strides into so many areas of the industry. How did you come about in deciding that virtual production through game engines and real-time rendering were really an area that you wanted to focus in your studies?
Actually, I have to admit that it was a graduate student that first turned me on to this whole thing, and this was back in 2012, 2013. This student was working on a thesis to develop a virtual camera system, and he was brilliant. I mean, it was his research, and he had worked out that with a game engine, he could create real-time graphics and using a PlayStation. And then because the game engine could compile for the PlayStation as well as a PC as well as an iPad, he actually merged all those devices together, and so that he could have an iPad with hand controllers on it, and he could use that as a virtual camera, and the game engine was updating camera position and camera parameters and all of this thing. And so this was back in 2013. He's, of course, he completed his degree then and has gone on to be quite successful, working on a variety of feature films and now episodic series. But really, for me, I had only recently joined Drexel at that time, and my background was primarily in animation visual effects for feature films, for television, and so game engine really had not been on my radar when I first arrived. But really, the work that this student was doing really opened my eyes to what it could do, and so I started diving into it myself at that point, and that was one of the things that really became an advantage for us as a program, as a department, as a university, is that we're not just traditional art school, we're a research facility as well. So we're always looking for, what is that next thing? So really it was back then in 2013 when we started working on these things, and that's what got me started on it. And then along the way, the technology just kept on getting better and better and better. And as our student base grew, that meant that we had more labs, that we were installing more computers with more GPUs, and it became increasingly useful for us to be able to leverage all of these things at once. So that's where it really all started. And of course, now again, it's matured to where a lot of the tools for performing these tasks are now built into the engines themselves, whether it's Unreal or Unity. They have built-in tools now to accept live camera feeds and the motion capture data, whether it's a full body person character or just the Sputnik of reflectors on top of a camera, so that every bit of camera motion that's being done in the real world is now being immediately translated into the computer. So a lot of these things that used to be a lot of custom coding and a lot of custom development work is now, we're benefiting from that now because it's mostly built into a lot of the systems.
Do you think one of the advancements of that the industry has seen is the fact that we've got far closer to traditional imagery, or at least the photorealism of imagery as we're used to, and we've gone away a little bit from the traditional sort of animation and visual effects or computer graphics that looked like it was computer graphics? Do you think that's one of the main advancements, is that we sort of narrowing the gap, between live action and visual effects in a way that's even more seamless than it's been in the past?
I think especially when it comes to real time, that gap is closing, and even when it comes to digital humans, really on that cusp of the uncanny valley, like coming out the other side of it, where you can have very authentic looking human characters in a real-time game engine, executing performances or responding to things like facial animation capture with using 3D depth cameras that are built into phones now. I think that the technologies that we've been using in feature films for decades, being able to take photographic reference and translate that through tools like photogrammetry to create authentic, photorealistic duplication, digital renditions of the real world. That in feature film, for several decades has been the norm, but I think it's the computational power, especially GPUs. Now it's routine to be able to have a GPU, and it has thousands and thousands of processors that are acting on thousands and thousands of pixels at once, and so we're able to do these calculations that used to take hours or days can now be done many times a second. And that really helps us close the gap in photorealism at the real-time level. At the same time, we're still working in a completely digital realm, and I think that it's very exciting that we can actually branch out and go beyond photorealism. And so, I've seen recently some productions that are done in this virtual production format that look very painterly. It was, pieces that are designed to look like they were moving impressionistic paintings. Being able to do cartoon characters and create episodic television without having, hours and hours of render time. You can just see your renders instantly. And we're also seeing it in broadcasts. So broadcasters like Fox Sports and the Weather Channel are using the same technology to do live television broadcasts. And some aspects of it are intended to look photorealistic, but other aspects are stylized. Clearly, if a race car rolls in front of a sports commentator, and that race car virtually explodes and bolts are floating in space, it's not meant to be photoreal. It's meant to be spectacular, but it aids in communication in terms of being able to explain, a particular moment, a particular event, and what transpired and what the physics are behind that, and what the design thinking was when components of a car are put together. So it's a really exciting time because we have that full spectrum of visual acuity to work with now.
So I'm in New York here. I'm pretty isolated in my studio, but everything behind me is real on this side. It's a real camera over here. But I'm not so sure that what's behind you is real. So tell us a little bit about, your environment and how you work, all this isolation, how you've been able to continue to manage to sort of learn and teach, and get some new stuff going with your students. I see that you're a big proponent of technology. We are very glad to have you as a tremendous customer of ours. But tell us a little bit what you set up, what you're running, how you use it, and what your intention is with putting what you have, your mini studio over there, put that together.
Sure. Yeah, I think, for me, one of the most exciting things right now is that all of these technologies are available, and they're, some other components are completely free, particularly to educators, and all the other components that feed into it are fairly routine, have been around for quite a long time, and are readily available. So what's happening here is I'm in a virtual production studio space. So what you see behind me and in front of me, including the desk that's reflecting my hands, all of that is a real-time virtual studio. It's built in a tool called Unreal Engine from Epic Games. And so this is literally the same tool that's used to create Fortnite and other video games. And it's also the same tool that's used for, producing virtual sets on the big LED panels as The Mandalorian. But I'm leveraging it in a little bit of a different way. I am in the basement of my home. If I turn off the virtual studio, you'll see that, of course, it's just a green screen. And the green screen I have is a very inexpensive 5-foot by 7-foot. It's got a little metal ring in it that it pops open. It's wonderful because when it's popped open, it's really, really smooth and very even and easy to light. And then it just twists and collapses into a little disc that, can slide between, behind a piece of furniture and can go away. But with that green screen, of course, then I can turn on the virtual studio, and everything that is behind me in the studio, I can configure the camera to have shallow depth of field. Again, coming from a feature film cinematic background, I want the imagery to look compelling. So I'm using a wide aperture on the virtual camera so that the background is out of focus. I use this now for all of my routine teaching Zoom meetings with students and regular meetings. You can see I have a little bit of a holographic screen in front of me that it is live. So there's one computer running Unreal Engine that's creating the studio. My other computer that I use for teaching demos or Zoom, or right now our little Skype call, is running on that machine. That is actually using a tool that's it's a free download for PCs and for Macs. It's called NDI Tools. It's from Newtek, and it's really just a networking technology that allows video to be shared in a similar way that you might use like an HDMI cable or an SDI cable from a video camera, but instead it runs over IP, Ethernet. And so I'm able to send the video screen from my second computer over to the Unreal Engine computer, and then I'm bringing that up as a hologram so that you should be able to see through it. My hand shows through it. I actually added this to the studio because the computer that's here, it's to my right, frame left, I guess. That's where my screen is on my desk, and when I'm looking at students or someone I'm meeting with on Zoom, without the hologram there, it looks kind of silly when I'm looking that way. But with the hologram there, now you can actually see what I'm looking at. And if I were to, this is my ATEM audio mixer, and I can, switch to the control panel for that. And so you can actually see what I am seeing in my real world space. And so that's the setup. And Unreal Engine is calculating all of this live so that I have it's a Blackmagic Studio camera is running into the computer. That video is being keyed immediately. The reflections are being calculated real time. And then that result is then, in this case, we're using Skype. So it's being fed through a Blackmagic ATEM Mini that's sending the video into the computer as if it was just a webcam. And so then that's how this works. And so, for me, it's an incredibly compelling teaching tool. I think that my students seem to find it refreshing that they're seeing someone who's not necessarily just in their home. Even though I am just in my home, I can make it look more compelling than that. I can incorporate 3D graphics into my demos. And, we're looking at leveraging this in teaching in a lot of different categories, not even just for immersive media or animation visual effects, but with the other colleges in our university, like engineering and nursing and others like that, where we can actually utilize these tools as a teaching medium.
So your main computer for what we're doing here, which by the way is also via NDI technology, so it is pretty prevalent whether you do real-time graphics or implementation of IP technology. NDI is very prevalent in our industry. But the question is, what's behind the scenes on your mini studio? I think you're running everything out of a laptop.
Well, it's not entirely out of a laptop. I am using a laptop to control things. So I think that let's see if I do this and this. Hopefully that's the wrong button. There we go. Okay. So this is what my desktop looks like right now. There are two monitors with keyboards on the desk. These are running desktop machines. So this desktop is running Skype right now. And so that's what we're communicating through. And the desktop that's driving, this keyboard, and there's another screen over here, that's running the Unreal Engine. So this it's actually an older generation GPU. It's a GTX generation Quadro board in this computer that's calculating the actual Unreal Engine Virtual Studio. The laptop I'm using as a demo tool. So I might have imagery here that I want to show, and so the nice thing is that both of these screens, this is an Asus Duo, ZenBook Duo, so it has two screens built into it, and they are both touch screens. So if I were to show one of those, let's see what I can do here. I can turn on this and go to this and go to this. Okay, so yeah, so all of this video switching that I'm doing is actually happening with the ATEM Mini, which is right here. So this is actually, education pricing is a little over $250 for one of these, and this is 4 HDMI inputs on a switcher that also has a USB output that allows it to be used as a webcam. So this is switching from all my different video sources. This is what's doing my split screen right now. And then on my desk, this laptop has software that's controlling that. One of the interesting things with this is that I can actually show 3 screens at once with the A10 Mini. So what you're seeing now is on the top portion is the actual display, the main screen of the Asus laptop. On the bottom of you're seeing, actually it's a Pocket Cinema camera that's just looking at my desk. And then of course the video feed from my studio camera. So this touch screen here, you can see is I'm actually using my hand on the touch screen to move the transition slider on the A10 Mini control software. So that's kind of handy. But then, I can still use this screen. This screen here is being fed as an HDMI input into the A10 Mini. So that's on preview right now. And so if I switch over to that screen, now this is a picture of our main studio with a large, 25-foot green screen and the mocap system and all of that kind of thing. So it's nice because, again, with the touch screen, I can, poke with the screen and then change, what I'm looking at. This is a virtual studio that we're actually working on building for our engineering school to use this fall when they're doing any kind of hybrid or distance teaching. So there are actually 3 computers being used in this particular moment. The laptop is being used as a primary control system to kind of run the show. One desktop is being used primarily for the external comms and the streaming, and then the Unreal Engine desktop is being used to actually create the virtual studio that we're seeing. And so I can switch to just that. So that's kind of that's the overall layout.
So the question, it brings actually an interesting question. In the end, the skill set that people in the industry need to have is far more varied than it used to be. Because we're seeing you're pretty well versed in computer graphics technology, but now you also understand streaming, you understand multi-camera production, you understand routing, you understand live switching, you understand green screen. So do you see all these technology, all these disciplines sort of merging into something that needs to be leveraged differently, at least in the formation of the new generation of professionals that come out of the school? Do you think it's important for them to understand beyond what their sort of area or predilection is, and be a little more well-rounded? I mean, you had a very interesting panel that I watched a couple of days ago about gen locking sources. Gen locking is a very video term. It's a very broadcast term, to make sure all your cameras and all your sources are in sync. You were talking about gen locking in the world of Unreal. So tell us a little what you think about, the type of skill set that people who want to get into this industry need to be focusing on.
Well, I mean, again, it kind of depends on where you want to start and getting your toe in the door. So I definitely strongly believe that it is important to have an area of strength that's considered your own specialization. I mean, I'm lucky. I'm an old guy, right? So I started computer programming, computer graphics in the 1900s, in the 1980s. So I've actually been, programming computer graphics for a period of time that I care not to really calculate at this point. So over the years of working in those spaces, I've had a variety of opportunities. My first exposure to Genlock, for example, was working on feature films where we were using the cameras to actually drive motion capture of props and well, in that particular case, it was someone's head. And so that was when I first learned about Genlock. Had I not worked where I did in features, Genlock would be a completely alien technology to me. But that that wouldn't necessarily prevent me from getting involved in virtual production. So I think that, when I look at my students in the undergraduate level, they're coming up out of high school. The vast majority of them are not going to have much, if any, experience in 3D graphics or any of these tools. Maybe if they're, maybe did some work with the television studio at their high school, they know a little bit about cameras. So when we have an undergraduate program, we kind of approach it with the idea that we are going to share a broad spectrum of skills with our students. And so if they're coming in for 3D animation or visual effects, where 90% of the work is actually going to be digital and on the computer, they still start out working with camera, learning about physical camera, aperture, ISO, shutter speed, and understanding how all of those things work together, and then how to use the camera as an artistic compositional tool, and then how to use the camera as a acquisition, as a resource tool, how to capture textures, how to capture geometry with cameras. And then those students should always have that with them, so that if they were ever in a scenario where they need to use a camera as a video source, then they'll remember some of these things. And hopefully as they progress through their career, they'll develop more awareness of how these things integrate together. For those of us that have been in the industry for some time, it's always important to work out how do these things play together. And for me, again, as recently as 2012, 2013, I had not worked in a modern game engine. When I was coding anything that was a game, it was in basic, like basic numerical lines, basic, or machine language or something like that on a Commodore 64. So the dawn of these amazingly powerful yet quite easy to learn game engines like Unity and Unreal in particular. It's not the kind of thing that traditionally someone involved in animation or visual effects might really dive into, at least not in, over the past several years. But really in the last few years, these tools have become integral to the production process. I mean, even before they became part of what was being displayed in front of the camera. When you look at a production like Mandalorian, where a real-time Unreal Engine scene is being projected onto an LED panel behind the characters, and the camera is capturing the entire scene in take for a third of the shots or so. That's relatively new in terms of mainstream production, but prior to that, these engines have been used as pre-production tools for a long time. They're very fast to work with. They're very fast to iterate through. So when you're planning out what we call an animatic, like just kind of like a playing with Legos kind of version of a scene, you can work with it very rapidly. And so even students or professionals that are focused on 3D animation, learning a game engine maybe sounds like a little bit out of the box, but that's less and less the case. So yes, you should get into game engine, and more power to you if you understand camera switching and streaming, and the difference between SDI and HDMI, and the difference between timecode and genlock. I mean, there are different things and what they are. All of those come in handy, and as these technologies that used to be quite separate now converge in this area called virtual production. Being aware of these different technologies, these different tools, and how they come into play is really, really useful.
Last question is going to be sort of a projection of what you see as the future of our industry. Actually, it's a two-part question. The first question is, what do you think the next development that you're going to need to attach to your curriculum is going to be? That's a projection. The other projection is, what do you think the advent of LED screens, LED panels, and the real-time capture of a visual effects type scene is going to change the landscape of visual effects in general, away from traditional green screen and blue screen?
So I think that a lot of that transition, that a lot of people talk about has happened. I mean, it is happening now, and it's been in play for a while. I think that there's always going to be a place for green screen. There's going to be productions that don't have the budget for a full LED panel display. There's also applications for green screen particularly in live broadcast, because it's very configurable, and you don't have to swap out the ground. even if you were using LED panels, I know that there's LED panel solutions for the floors as well now, but the green screen's going to be around. It's just a different solution than LED panels. With the LED panels, certainly much more can be captured by the camera in actual takes. One of the things that I'm not ashamed to share is, watching The Mandalorian and discovering that there's an office scene where the lead character is played by Werner Herzog, and I never guessed watching it for the first time that the office around him was actually being projected on an LED panel. That has a huge impact in production, because the director can work very rapidly and iteratively. They can try new lighting instantly without having to move lighting instruments in the physical world. You don't have to strike, and reconnect and repatch anything and move hardware around, and that could be dangerous. So there's a lot to do when you're rigging and moving actual hardware lights. But when you can change the time of day or hold the time of day, you can have magic hour for a full 8-hour day. Those types of things open up a lot of flexibility for directors working on set. And that comes into play for music videos as well as broadcasts. There's just so many applications for that are normally, much more complicated and much more expensive and take much more time. So we'll be able to see things iterate more quickly. Again, we're already seeing in broadcast how this technology is used with green screens. It's also being merged with live action, right? So we're seeing Fox Sports with their Super Bowl broadcast. They're using, these real-time graphics to add spectacular three-dimensional graphics onto the field. So they've got a camera moving through the stadium. It's showing a live feed from that stadium, but then 3D graphics are overlaid onto that as if they're sitting on the field. Or with baseball, Fox is, adding stands full of people at a time when, in-person audiences aren't possible. So the funny thing is that all of this is the present. So the future is all of this is going to become more prevalent, and it's going to get faster, and the quality is going to get better, and we're just going to be seeing more and more of it.
New tools, for the creative minds, right? I think that's really how we could qualify the nature of our industry. Very nimble, very innovative, and I think some of the advancement that we've seen due to the pandemic also have applications that go beyond the fact that we are isolated. I think it's incredible that advancements have been able to sort of come through in times where it is real delicate, to engage in production, and we're finding new ways. So I think that's probably part of your role, is to educate people into becoming familiar with the new production techniques that come out, in the industry.
Yeah, I would say that I think the most important thing to understand is, while a lot of what we talked about is rather expensive, high-end, complicated equipment, this can be done right now with a webcam, or you could use a mirrorless camera that's able to be used as a webcam, and you could, or HDMI out into an 810 mini, get that into your computer. That, Unreal Engine is 100% free download, and as long as you have a good graphics processor unit, a GPU, again, the computer that I'm using right now, this is actually using an older GTX generation graphics card. But of course, the newer RTX cards that are available now do real-time ray tracing, so you get much more fidelity in the graphics. And a typical video game capable laptop that's current generation laptop comes with these RTX GPUs built in. So with very little additional investment, maybe it's just a capture board or an ATEM mini that allows you to feed video into your computer, into your laptop, desktop, and then Unreal Engine, you could get to work with this with very little upfront investment and start working with it. And I think that's another thing that we'll see, is that this will become increasingly accessible at more entry-level production scenarios.
Nick, fantastic. Thank you very much. It was a pleasure to speak to you. For those of you who have an interest in what we just talked about, we'll have Nick for a live Q&A. We'll post that on our website. So if you have any questions for Nick, he'll be part of a Zoom session most likely, and you guys are invited to come in and ask your questions. Aside from our programming, which we invite you to go to our website, to see what other programs we'll have during the SIGGRAPH days. Nick, I think you have a packed program yourself. What are you entertaining us with? What you're planning for SIGGRAPH?
Yeah, SIGGRAPH's kind of my thing. I love SIGGRAPH. I'm actually doing 2 particular events I'm working on with SIGGRAPH. So on Monday, I'm presenting a Groovy Graphics assignment with the Educators Forum. I submitted basically it's a talk on doing full dome virtual production and virtual projection. So that's with a colleague from University of Washington, Barbara Mones. So we'll be doing a talk on dome projection. And then I believe it's scheduled for Thursday at 1 p.m. Pacific time. I'm hosting a Birds of a Feather for looking at virtual production in education. So I'll be at both of those, available for Q&A and of course a B&H session as well.
All right, Nick, thank you very much. Stay safe, my friend, and hopefully when the world comes back to normal, we can see each other at SIGGRAPH next year. And tune in to our website or go to SIGGRAPH.org, where we'll also have a exhibitor page where you can actually engage with us and look at other sessions that we'll have. Thank you very much.